welcome to the DataPains channel. Today I want to discuss Apache Airflow. So Apache Airflow is an orchestration tool where you build up DAGs. And DAG simply means directed acyclic graph. So essentially you can trigger one job after another. Like for example, you move some data from a Postgres database, you load it to S3, you then have some other job that reads the data from S3, writes it into some other database or other table format, etc. And this sounds pretty simple, right? And Airflow is great for those kind of basic workflows where you need to move something to another place. You can run it with a cron, so like hourly or once a day, once every month, and everything's Python based. So pretty straightforward. However, I am not the biggest fan of Apache Airflow. And I wanted to go into some examples of why I would advise not to use Airflow if you have the choice given your requirements. So I will go a little bit more into event-driven architecture where Apache Airflow simply just fails. There are a lot of people trying actually to use Apache Airflow to make it event-driven, but this is simply just not what it was made for. And I've just had so much pain in the past trying to scale out an existing Apache Airflow deployment where actually the pipelines that run, they should be independent of each other. So some data updates, some job run, maybe there is some, maybe there isn't any. There's a lot of benefits with having it more stateless and not having a monster DAG with 500,000 steps. But yeah, let's dig into it. Okay, so let's jump straight into it. So here we have an example now where we have some backend team. They are managing a MySQL database. In this database, they perform inserts, they update, and they delete. And we have a table X that we want to sync. And we want it to end up in an Apache Iceberg table. Right? So, before thinking about Apache Airflow or anything like that, you probably want to have two types of steps. So the first one would just be to extract the data, like new incoming data based on a timestamp or whatever. And then I just append it to the table. So append strategy is very straightforward, without going into details. And then essentially that, okay, I'm going to have some deleting going on. So I need another step to go and check my deletes. So here you would have another step that would go look at the existing IDs, compare with the iceberg table. When it finds a difference, it would delete it. So for example, we have synced previously ID 123 to iceberg. Now ID 3 is gone from the database. We're going to delete it. You could also do a soft delete, which probably is preferable and better. But I just want to visualize something to make it easy to understand, right? And this is a very basic flow, and you could write this, in many different, ways. You can make this happen in many multiple ways. However, let's imagine you go down the route of using Apache Airflow. So Apache Airflow, this is a straight copy from the documentation, right? So you have someone who writes DAGs to a DAG files, like a DAG folder. This DAG folder would usually live in a separate GitHub repo or GitLab if you use that. And as you're publishing your DAGs, so in this scenario, maybe we would have either an existing operator in the library of Airflow that you can just use, hook up, and pass on, or maybe you write your own custom operator. So let's imagine you have written your own custom operator for this one and for this one, and you have separated them into two different pieces, but they are part of the same DAG. You publish them to the DAGs folder. Depending on how Apache Airflow is deployed, it can be in Kubernetes or Celery or, whatever. It doesn't matter. I'm not going to go into details. But as you push this, the scheduler in Airflow will pick up that the volume has changed on the DAG side. It will look at, okay, when should I run this? Okay, I'm supposed to run this hourly. It writes to the internal metadata DB the state of this DAG when it should run, and make sure that it runs when it's supposed to run, a simple cron job. And you can then see all of this through the UI. So as you build your DAG, in this case, it would be 2 steps. Very basic and not a problem necessarily. And that would be it. And then you could operate the DAG from the UI and you could see this run. And this is a pretty basic use case. However, let's now imagine that we have a cascade of events happening. So imagine that now we go from one iceberg to another iceberg to another iceberg. So let's use the medallion structure. So let's imagine that this is table X bronze. This is table, this is table X silver, and this is table gold. Okay, and we need to propagate changes between these. So you need to create new steps. So maybe here, we have one custom operator, which is like bronze to silver, right? And you get the point. We would then have something here, but now instead of bronze silver, it will be silver gold. And this is some kind of presentation layer, or a data set for a machine learning model, or whatever it might be. So this DAG, we will start to build it up. So we will end up with something like, okay, it will start with essentially extract data. The second step will be append data, right? And this is your operators in the background. And then it will be delete data. And then you'll have another step, which essentially propagates to silver, to gold. And you can do this in Airflow pretty straightforwardly. So it will just jump between these steps until it reaches its final destination, right? And so far, so good. This is not very complicated. But then you end up in a situation maybe where, okay, now I'm doing it for one table. Now I'm going to do it for a second one, and a third one, and a fourth one, or in this case, up to n. So, this DAG, it just grows and grows. So we end up in a situation essentially where we have tons of these running at the same time. And then to complicate things, not only this to that is needed. Then you need this to run before you can run this. And maybe you need this one before you can run that one. And essentially what's happening now is you're starting to get a super complicated flow where one thing needs to wait for another. If something fails here, it won't go here, and then everything else might fail. So you might have something like this, essentially. Sorry, not like that, like this. So you might start getting these weird dependencies, right? So I'm just trying to visualize without Airflow in mind necessarily, but kind of. Just imagine that you start getting this flow here. And actually, when we look at this flow here, you don't really need, this here doesn't need to run in this rigid way, right? You could actually just achieve this by having something that independently grabs data from here, writes it to here, and then you could have something independently that checks soft deletes or hard deletes on its own schedule. You can make sure that they don't collide. You can then propagate these completely independent on when the bronze table succeeded. So let's say you run this in dbt, right? And you do this, and you have to wait for this to run for that. It might make sense in your mind that these jobs here must succeed before I run this. Otherwise, it makes no sense. And if you think about one single table, that makes perfect sense. But when you start getting a flow like this, actually, what is hindering you from just doing something like this, where essentially to Silver can run independently? Uh, all of these can run independently. They don't necessarily need to wait for each other. What they do is, so this is a completely different way of architecting data pipelines completely. But so imagine that you have uh, all of these living by themselves. So it means that you build a pipeline where these steps are individual. And for example, you have something that extracts data. And obviously these would live together probably in the same step, right? But imagine that these run, they append data on their own, constantly. So this could be, a standalone application. It doesn't need to be Apache Airflow. It doesn't even need to be a DAG. These two steps can be a DAG in itself, right? So you could use another tool like Org Workflow or something like that, which I'm not going to go into here. But essentially, this could run by itself. This could run by itself. This could run by itself, and this could run by itself. So if you have, let's say, DBT incremental, or you're running maybe a smoker with a merge, upsert, whatever, and you make sure that you have all these flows incrementally set up, then as this gold one runs, you can run it more frequently. And if there is new data, it will merge it in. If there isn't any, it just won't do anything. Same thing as Silver. So the trade-off here is you potentially run slightly more often, but you get much lower complexity. So you end up in a situation where all of these things, they run independently from each other. One adds from the output of the other, but they don't have to wait for each other. And this is really something that does not work in Airflow. The whole mindset in Airflow is to strictly force you to run something after another, after another, after another. And when you get in these situations where maybe you are writing to like 100 tables, 1,000 tables, or you're doing complex transformations where if something fails, you don't want everything to fail. That's where the architecture of Airflow kind of breaks and falls apart, and people try to make it event-driven, and I'm going to trigger this DAG when that other DAG has succeeded, and this with that. But it ends up being a complete over-engineering. So this is why I don't like Apache Airflow. And this is why I think you should choose other tools, such as Argo Workflow or similar. Feel free to contact me if you disagree or agree. Have a great day.